You press the power button, wait a few seconds, and a login screen appears. But what happened in between? There's a whole chain of handoffs, firmware to bootloader to kernel to the system that brings up everything you see. Let's trace that path from the very first millisecond. The moment electricity hits your motherboard, firmware takes over. On older machines, this is BIOS. Newer ones use UEFI. It runs a quick hardware check called POST, making sure your RAM, CPU, and drives respond. Then it consults the boot order to pick a disk. Once it finds the right device, it reads a tiny piece of code from the very beginning of that disk and jumps to it. On a UEFI system, it loads a file from the FI system partition instead of reading a raw sector. Cleaner, but same idea. GRUB, the Grand Unified Bootloader, is what you see when you pick between operating systems on a dual boot setup. But its real job is more fundamental. It locates the Linux kernel on your disk, a compressed file usually called vlinux, loads it into memory, and hands it an initial file system called initrums. That tiny archive contains just enough drivers to mount your real root partition. Think of it as a skeleton key that lets the kernel unlock the rest of the system. GRUB also passes on boot parameters, things like which console to use or whether to boot into single user recovery mode. Here's the whole chain in one view. Firmware starts first, locates the boot device, and hands off to GRUB. GRUB loads the kernel and the temporary initrums file system into memory. The kernel unpacks itself, detects hardware, and uses initrums to mount your real root disk. Then it launches system D, which takes over and starts all the services that eventually bring up your login screen. Each link is a handoff. The previous stage becomes irrelevant once the next one is running. Once the kernel is in memory, it decompresses. The on-disk image is typically 2 to 3 megabytes, but balloons to 5 or 10 uncompressed. It sets up memory management with page tables, starts the process scheduler, and begins probing hardware. CPU cores, drives, network cards, USB controllers. It mounts your actual root file system and discards the temporary initrums. Then it executes the very first user space program, which on modern distros is libsystemd systemd systemd. That moment is a hard boundary. Everything before runs in kernel space with full hardware access. Everything after runs in user space with normal permissions. Systemd is process number one. Every other process on the system is its descendant. It reads a target, which is a preset for what this machine should become. On a desktop, that's graphical.target. Then it starts services in parallel, networking, audio, Bluetooth, logging, cups for printing, whatever your system needs. One of those services is the display manager, GDM, STDM, or LightDM, which paints the login screen you finally see. On a typical laptop, this whole phase takes under 2 seconds. If you're ever wondering what took longest, run system deanalyze blame. It shows every service sorted by startup time. So that's the chain. Firmware hands off to GRUB, GRUB hands off to the kernel hands off to systemd, and systemd builds the world you log into. Next time you want to watch this in real time, just remove the quiet and splash parameters from your job config and reboot. You'll see every step scroll by.